Hello students, I am Dr. Shilpa K. Gowda, Associate Professor, Department of ACE, SJBIT. Today I am going to explain the concept of a communication system. So in this, first we will start with the cellular telephone system. So before that we will start with what do you mean by cellular concept. So we know that in the early phase, a mobile radio station normally used a high power transmitter with an antenna mounted on a tower. This approach gave very good coverage, but it was very difficult to reuse these same frequencies. Therefore, the network capacity is low. As the demand for mobile service increased, achieving high network capacity by the same radio spectrum was more important than covering large areas. In order to solve the capacity problem, the cellular concept was proposed. The fundamental principle of the cellular concept is to subdivide the large geographic area into small sections called the cells, which are served by their own radio base station. And each cell use the concept of frequency reuse to increase the capacity of a wireless and a mobile telephone system. So next we have a cellular telephone system. So the cellular telephone system use the basic components are mobile station, cell, base station and a mobile switching center. Where mobile station, this is the mobile handset which is used by an user to communicate with another user. Next we have the next component is a cell, where each cellular service area is divided into small regions called cells, that is from 5 to 20 kilometers, and each served by base station. Cells are typically hexagonal in shape. Next we have the next component has a base station. Each cell contains an antenna which is controlled by a small office. Next we have mobile switching center. Each base station is controlled by a switching office called a mobile switching center. So next, the main concept of this cellular concept is that frequency reuse. So frequency reuse is the core concept of the cellular mobile radio station. The total available channels are divided into number of channel sets. Each channel set is assigned to a cell. Cells are assigned by a group of channels that is completely different from neighboring cell. Cells with the same alphabet use the same channel set. The same set of channels can be reused in another cell provided that the reuse distance d is given by d equals square root of 3n into r, where n is the number of channel set and n equals 7 and r is the radius of the cell. So, that is in frequency reuse concept, the radio channels use the same frequency to cover the different areas that are physically separate from each other. Here, a single transmitter of high power cannot be used to cover the entire area. Instead, many transistors of small output power operating at the same frequency can be used. Reuse improve the spectral efficiency and the signal quality. So next we have wireless network topologies. So this wireless network topology is defined as the arrangement or structure of interconnected devices in a wireless network. These topologies determine how devices communicate with each other, share resources and form connections within the network. But basically, there are two types of topologies used in wireless networks. They are ad hoc network topology and infrastructure network topology. Next, ad hoc network topology. Ad hoc network topology is nothing but peer-to-peer technology. That is, in ad hoc network topology, devices communicate directly with each other without the need for a central access point or infrastructure. Each device in the network can act both as a transmitter and a receiver. And communication is established dynamically between neighboring devices within range. So next, within ad hoc network, we have two types. One is a single hop ad hoc network and other one is a multiple hop ad hoc network. So in this network, that is in single hop ad hoc network, every user terminal has the functional capability of communicating directly with any other user terminal. And also nodes within an ad hoc network can only communicate if they can reach each other physically, that is if they are within the radio range. Next, we have multiple hop ad hoc network. In this multiple hop ad-hoc network, users are distributed over a wide area. A given user terminal may be able to reach only a portion of the other users in the network due to the transmitter signal power limitations. In this situations, in these situations, user terminals will have to cooperate in carrying messages across the network between widely separated situations. These networks are called as multiple hop ad hoc network. Next, we have infrastructure network topology. So in this infrastructure network topology, there is a fixed infrastructure that supports the communication between the mobile terminals and between mobile and fixed terminals. This topology is defined for large coverage areas and multiple base stations or access point operation. Here, in this, base station serves as the hub of the network and mobile terminals are located at different positions at the end of spokes. Any communication from one wireless station to another comes through the base station. The hub is involved in managing the user access to the network. Next, we'll start with the first generation 1G telephone network. So first generation technology. In this first system developed to provide basic voice communication services using analog radio signals. This 1G system uses analog modulation techniques such as frequency modulation or amplitude modulation to transmit voice signal over radio waves. One example of a voice communication is an advanced mobile phone system, that is AMPS. It is an analog cellular phone system. It uses 800 MHz ISM band and two separate analog channels, forward and reverse analog channels, where the band between 824 to 849 MHz is used for reverse communication from mobile station to base station. The band between 869 to 894 MHz is used for forward communication from base station to mobile station. And also AMPS uses a frequency division multiplexers to divide each 25 MHz band into 30 kHz channels. And also this 1G network supports basic voice calls and lagged features such as text messaging and data services. Next, we have second generation technology. In this, the second generation communication system was a major advancement in mobile telecommunications technology, transmitting from analog to digital communication. This 2G system uses digital modulation techniques like QPSK, that is quadrature phase shift keying, and Gaussian minimum shift keying, GMSK. The main goal of the 2G communication system was to improve the voice quality, increase network capacity, and to introduce basic data services such as text messaging. The three major systems evolved in this generation are IS-136, IS-95 and a global system for mobile. So next first one is DAMS. DAMS is essentially a digital version of AMPS. Here each 1994 bits divided into 6 slots shared by 3 channels. Each slot has 324 bits and it uses both the TDNA and FDMA techniques. IS-95. It is based on CDMA and FDMA technologies. Next, we have GSM, that is a global system for mobile communication. In this global system for mobile communication, it consists of mainly three major subsystems. They are mobile station, base station, and a network and switching subsystem. This subsystem will interact with themselves and with the user through some network interface to establish the communication. First, we'll consider the mobile station. The mobile station consists of the physical equipment used by the subscriber to access a mobile network. The mobile station is divided into two parts. The first part is the mobile equipment, which contains the hardware and software to support radio and human interface functions. And the second part is subscriber identity module, that is a SIM. Next, we have base station subsystem. It handles the traffic between MS and NSS. It contains two main components, base transceiver station and base station controller. BTS, that is base transceiver station, consists of equipments that communicate with mobile phone, and BSC is used to allocate the time slots between BTS and MSA. Next, we have the next third component or the third block, network and switching subsystem. So it tracks the location of a caller to enable cellular services. This NSS consists of five functional units. So first one is mobile switching center. It performs a call setup, call release, call tracing, call forward and a short message services. Home location register. So it subscribes HLR subscribes ID plan that subscriber using caller tune, location authentication using SIM cards. Visitor location register. It contains exact location of all the subscribers currently present in service area of MSA. Equipment identity register. It is a database consists of a list of valid mobile equipments on the network and a record of all allowed and banned users in the network. Next, authentication center. It performs authentication of subscribers in the network. AUC is accessed by the HLR to determine whether an MS will be granted services. Next, public switching telephone network. It is a network of a fixed line analog telephone system connected with the MSA. Next, we have general packet radio services. It is an enhancement to GSM technology and it provides a powerful data transmission. It is based on the principle of a packet data transmission, and data is broken into small packets of data and then transmitted. Thank you.